Hello guys, once again welcome in my channel. Today we will do a artificial intelligence uh, practical lab practical. Because without practical knowledge, any subject if you read it is incomplete. So let us start this video and we'll see how to do the practical on artificial intelligence. Thank you and stay tuned.
Yes, sir.
Yes.
अच्छा मैं सारा समझा बैठा हूँ लेकिन कोई बात नहीं I'll explain it again. No problem. See, this is a neuron basically. Our whole body is connected with neurons. Whole body is connected with these kind of neurons, right? From the legs, hands, everywhere. This is the what we call the smallest portion. So what will happen? This is dendrites. Through the dendrites we receive the signals, and this is the axon. This is the axon. Through axon it is just like a wire which is used to transmit the signals to the another neuron, because there is a chain of neurons in our body. So and there is a thing that is what we call synapse. Synapse is basically used to connect two different neurons. So this how the biological activities in our body get done. Now if we are talking about the artificial intelligence, so definitely, since in our body the intelligence is transmitted through this neuron, so similarly we should have an similar kind of thing artificially we should have, so that the information get transmitted through it. I'll show you what is this. See, this is the artificial neuron. Artificial neuron, what it do, it takes an input and give it to the output. So let us see how they are similar to the biological neuron. What is the difference between biological as well as the artificial neuron? See, as in biological neuron there is a cell nucleus. There in artificial neuron there is a node. I'll show you. See, this is a nucleus. Here in an actual neuron, in the same way in artificial there is a node. This is node. Dendrites, the thread-like structure that I told you, that is for taking an input. Similarly, for artificial neuron we have an input. Synapse is basically to calculate the result, to give it to the pass on the things to the others. Similarly, there are weights or interconnection. Axon in for output, and this is for output. So if we see the artificial neuron at a glance, you see what is this, what actual this neural network is. See, actually this Frank Rosenfeld in 1928 to 1971 he discovered this perceptron. Now what is this perceptron? This perceptron is basically a device. It's a kind of logic like in human body. Human body is how human body works. We see the things, analyze the things, and then if we likes us that thing, we accept it. Otherwise, we rejected it. The same perceptron, artificially how it is designed, it will see. Actually, what will happen? I will not say Rahul is a good boy. Only on one thing. Like Rahul greet me every day. He every day said me good morning, good evening. So I can't say Rahul is a good boy. Because only one factor I can't say he's good or bad. I should have to take all the maybe greeting is one of the factor that somebody likes. Yes, if somebody greets you, he is a good or bad. But not only greeting, his dressing sense, and there are so many things. Dressing sense, and his voice, and his there are so many factors. I think you understand. There are so many factors on which we can say somebody is good or bad, and each factor has their own weightage. Like greeting, we will give greeting 0.1 weightage, because if somebody not greets you but his voice is so soft, and he is very polite and very handsome and very punctual, so there are so many other factors which makes him a good or bad. And each factor have a different weight. Like voice, we will give 0.5 weight. So this is the weight that is decided by by us basically. Like if I want to recognize your face, if I want to recognize somebody face, so I will give some weightage to the eyes, some weightage to the nose, and some weightage to the lips, and also some weightage to the ear and hairs, forehead, eyebrow. So but let us suppose there is a mark on his face. Shall we have to whether we ignore this? No, we should have to give some negative weight to it. If somebody have mark on, or maybe some mark on some at some location which feels the person is smart, makes the person smart, so we will give different weights to the different things to. And circumference also, the circumference also. So the different things, what I want to tell you, when we see the things, we see many things altogether, and which has the different weights, and on the basis of all the calculations, we create an impression or image about somebody. Yes, he is good or bad, or yeah, his shape is round, or he is something like this, and this is totally depends upon the various factors. Similarly, perceptron is what? Perceptron is also a kind, and this is what we call perceptron. So how we like this here, the different positions have a different weights. These weights, there is one activation factor first of all. That activation factor takes the image of this, and then there is a weight. We multiply. There is a sort of calculation to calculate the weight, and there is a threshold. Let us suppose if you recognize a face, and I'll show you the cat face. So in a cat face, it is round, and it has some sort of hairs on the just above the lips. So there are so many factors. On the factors, at the threshold, at the end, it will the result will tell you yes, it is a cat. But next time I'll show him a picture of dog. If your if you if your calculation is such the way that at the end your function will tell no, it is cat, then probably your system is wrong. What I want a system such that it will extract the features and the weight. And for the different animals, different kinds of weights are there, and on the basis of these weights and calculation everything, you will tell whether that thing is particularly that or not. This is what we call perceptron, right? So this is how it works. It takes the inputs. This is if it is a single cell, then it is called single cell perceptron. If the multiple layers of single this if we replicate this thing one or three or four times, then it is called multi-layer. Since it is only a one layer, that's why it is what we call single layer perceptron. So in perceptron, the basic things you have to understand. It will take an input, and every input has a different weights. On the basis of these inputs and weights and functions, you will come up to certain decision that yes, it is that particular thing or not. This perceptron is basically used for classification. Now आप सब कहेंगे कि सर why we are doing this, why we are learning this. Actually, right now in the market, there is a neural network is very famous. What is a neural network? In neural network, they use this perceptron concept. We give some inputs to the perceptron, and perceptron will calculate it and then classify it according to the weights and everything given to it, the machine. Similarly, if you have a machine in which there is a which will tell you whether that is a particular thing or not. Let us suppose if you show an apple to the if you show this apple to as an input, the features of apple, And what is the features of apple? Like it is round shape, and it has red color, and it has one leaf or not a leaf, like it has a bump. So if your machines find these three things, it will tell yes, it is an apple. Now let us suppose somebody would put the image of apple like this, like a apple iPhone, which is यहाँ से खाया हुआ होता है जो, they show this kind of figure to this. So whether your machine is able to tell yes, it is an apple or not, this is basically we have to classify, we have to train our machine that it will look for this three things: round, red, and bump. But let us suppose it is a red figure and not completely round. So what kind of weightage you should have to given? Definitely apples are, probably it is red. Yes, I know there are green apples, golden apples are also available in the market, but for a apple, the most important characteristics is that it is red, and definitely so I'll give more weightage to this. Whether if my machine checked yes, it is a red color thing and it is a round thing, then probably it is apple. So it is apple. Then what is the accuracy? How much how much accurate it is an apple? Because it may be a ball also, or it may be a any other fruit also, which is red in shape, red in color and round in shape. So my whole sole concept I would like to tell you here is this method, like perceptron, how it is work. Now how it is related with our lab? Let us start our lab now. For the lab, I'll go for this is an online IIT Bombay lab, which is prescribed by the MHRD for the machine learning implementation. So I just picked this first initially. So we will do some practicals from here, that some simple practicals from here. Later on we will do the machine learning on a data analysis, that terms, supervised learning, unsupervised learning, we will do that also. But this is our first practical. I'll send this link, you need not to be bothered about that. I'll send this after my class. I'll send it in the group, WhatsApp group. So how to perform the practicals, you just have to see. This is a very important and virtual lab. Here this is your aim: to understand the working of neural network using AND, OR and NOT gate. Then if we are talking about the theory, this is the theory. This is all I already explained you through my this document. That is, there are set of inputs. It is nothing but the neuron. This is nothing but the neuron. And how neuron works? Neuron works according as the biological neurons works in our body. The artificial neuron is a single perceptron which is work artificially outside. Now in this we are performing AND gate, OR gate and NOR gate today. Today we will go to perform AND, OR and NOT gate. This is your first practical. So first of all, there is a pre-test for you, just to tell it's a kind of quiz whether you are able to perform this practical or not. So which of the following is the truth table for a NOT gate? You all see this. Which one is a possibly truth table for a NOT gate? Anybody from you?
Sir, option B.
Sir,
B. Okay. B is correct.
option B.
Okay, right. Option B is correct. So I'll mark it for you. Answer is B. Already it is, once you marked it, it is given to you. Yes, your answer is correct. So now my next question is, two input to the AND gate are 0 and 1 respectively. Which of the following will be the output when you provide 0, 1?
Sir, A.
A.
Sir, 0. Yes, sir, 0.
Zero answer. So if I select 0,
0.
yes, your answer is correct. Now move towards the next one. Which of the following is the truth table of OR gate? Yes, anybody? OR gate?
Sir, D.
D. Very good. Very good. D.
Yes, sir.
If I put D, yes, D is your answer. So this is a sort of a pre-request, pre-test. Yes, it gives me a clue that you understand NOT gate, AND gate, and OR gate. So now we'll move towards the procedure, how to do the lab. For that, you have to start. This is a procedure given to you. When you make your lab file, you just note it down. Okay, and see now what will happen. You know all the gates, truth table of the all the gates. What I assume, you know the truth table for all gates. Now what you have to do, this kind of graph is given to you like 0 on 0 to 0, this is a point. 0 to 1, this is a point. 1 comma 1 is this point, and 1 comma 0, because these are the four possible outcomes will be, after the, if we run the gate, we will get either 0 0 0 1 1 0 or 1 1. This is the four options are given to you. Now what you have to do, you have to make this partition in such a way that all the like terms are on the one side, means all the crosses are on the one side and all the triangles are on the other sides. Depending upon the which gate you are performing, you have to do it like this, right? So you have to set this, and for this you have to set the weights. I'll tell you how. Right now I am performing it. You just see it. When I go to the simulation, let me do the simulation for AND gate. This is the AND gate. This is a single perceptron. In perceptron, these are the inputs. This is a sigma function which is used to calculate this summation, and there is a threshold. If your result is less than the threshold, then means expected is 0, and if your result is less than under the range of expected, then it will give you answer 0. Otherwise the answer will be wrong. So before starting it, what you have to do, first of all you have to set the value of this line through the weights. This is the weight. By if you change the weights, you can see the lines and every function get changed. And if you change the second weight, you can change the slope of this line, right? So, and through threshold you can move it above and below. So what you have to do initially is you have to put it like that. You have to segregate. Basically, the machine, you have to set the threshold for a machine. Now I am setting it 1.5 and 1.5, around 1.5, which will segregated these points separately. Triangle represents 0 and cross represents 1. So if your machine is such a way that it has a clear distinguish between these terms, it will give the result more accurately to you. Now, so the very first step is you have to select this line in such a way, by setting the weights and the threshold in such a way, it will segregate these two terms separately. Now if you ask the machine for 0 0, let us suppose for 0 0, I want to check. I know for the 0 0 AND gate expected result is 0, but from neural network, basically by setting these weights and threshold, you set a neuron. Now my neuron is set. Once I start simulation, you see it will create a result, and probably it will create a 0, because you set the machine in such a way for 0 0, it will give you 0. See, you will get a 0. Now apply to the next set of the values. For 0 1, definitely it will gives you 0, because you set it correctly. Just wait, it is computing. Yeah, it is 0. Again for the next set, the values are, you see the values get changed. 1 0, when you give 1 0, all the calculation has been done by the machine itself, and the values come to be 0.95, which is less than 1.5, 1.3. So because you set the threshold 1.3, so it is, when it is true, the output is 0, it is okay. Now apply to the next one. For 1 1, you want 1, and your expected result is 1.9, which is false. So your result would be 1. Just wait, 1. So what if it is false, then it is 1. If it is true, it is 0. So now what I would like to tell you, let us suppose you place this value differently. You by chance, let us suppose you segregated your data in such a way, like it is not clearly separatable. Now what will happen if we run this kind of simulation? Let us start. If I start the simulation for 0 0, it will give you the wrong result, 1. Right, for 0 0 it will give you 0. It is okay. So apply to the next for 0 1. Yes, for 0 1 it is given you 1 because the data is not perfectly segregated. So this will show if you are not able to segregate the data well, means when you put the data inputs to this neuron and you are not correctly setting the weights, then probably it will give you the wrong answers. So this is your practical. This is a post test, like what you get when you set 0 0, what you get, you have to do this also, and the references at the end. So basically this is the first practical. Here I use the AND gate. You have to do it with the OR gate also, and you have to do it with the NOT gate also. For everything you have to set the lines, you have to segregate it properly, and I'll just explain the theory, and I'll advise you to just read this theory also. In this theory, they show you how they do the calculations also. Like when you provide 0 0 and you provide weight 1 1, weight you provide 1 1 and input is 0 0. Then how this is calculated, I'll show you. 0 into 1, 0 into 1, then it will come to 0. And for a signum function, you just have to read the signum function also. For the signum function, if the value is less than 0.5, then it is 0. And if its value is more than 0.5, like here, then it is 1. This is the property of signum function. Signum function you have to learn. Signum function, how it works: when the value is less than 50%, then it is 0. When the value is more than 50%, then it will be 1. So this is how this practical can be done. Anybody any problem, you may ask me.
Sir,
Yes.
sir, how to set the threshold? Is there any parameters?
Yeah, basically I'll tell you. See, threshold is basically, it is in your hand. You like a data is given to you. For designing a neural network, you have to be pretty sure to segregate data into two groups separately. Like, right? So
Okay.
on the to segregate them, you have to set your weights either by, there is no particular way of setting it. You have to decide it which one is the best possible manner to do that. Like if I am designing an algorithm for a facial recognition for a face, sometimes some people give most important weight to the nose or an eyes, but it is not always be taken. It is on the designer how they do that to select weights to design their own machine. So it's up to you how to take the values of the weight, right? But the most important thing is you have to be pretty sure that like here it is shown, your data must be properly segregated. Like if I'm talking about OR gate, let me show you OR gate simulation. If I select OR gate, see, OR gates have these 3 cross and 1 0. So I have to decide my weight. This is also okay. Once you decided weight, now the weight is 0.5 and 0.5. But if somebody make it more, sometimes what will happen, the result is not getting accurate, or it will consume, it will take some more time. Then you can select it more near towards your ones, right? This is also a possible way. Okay, so it's in your hand how to decide a weight. It is up to you. Or and threshold also.
तो सर जो आउटपुट आएगा उस पर फर्क नहीं पड़ेगा इस तरह से?
नहीं, आउटपुट में फर्क पड़ेगा. योर मशीन,
Like
योर, यस यस, आई एम टेलिंग यू. सी, आउटपुट में फर्क पड़ेगा. आउटपुट में बिल्कुल फर्क पड़ेगा. अगर आप इसको, इस डिस्टेंस को बिल्कुल इसके बीच में रखेंगे तो ये ज़्यादा एक्यूरेटली रिजल्ट देगा. बट अगर आप इसको ज़्यादा इसके क्लोज रखोगे तो वो कैलकुलेशन में उसके बिल्कुल नज़दीक आएगा, तो प्रॉबेबली वहाँ पे चांसेस ज़्यादा हो जाएंगे प्रिडिक्ट करने के. सपोज करो आपको बोलना था 0.8 पे, उसको बोलना था यस, लेकिन वो 0.79 पर भी उसको यस बोल देगा, जो कि 0.79 पे उसको नो बोलना चाहिए. So
Yes, sir.
this is why we make it, you know, in the middle, not always, you know, too close towards the, मतलब बाउंड्री को आप जितना परफेक्टली सेग्रीगेटेड कर देंगे वो उतना एक्यूरेटली रिजल्ट देगा. ठीक है. इट शुड नॉट बी टू क्लोज टू जीरो, इट शुड नॉट बी टू क्लोज टू द लाइन, द सेग्रीगेशन लाइन should not be too close to the zero and should not be too close to the ones. It may be, must be in between that.
तो सर मतलब we can take like 0.4 or 5 or 6 approximate.
Yes, you can tilt it like this also. By you can tilt it like this also. For a segregation you can do anything. So this is what I'll give it to you. You just go and you know, try this practical for an OR gate, NOR gate, NOT gate, and comes up with your, you know, different solutions. Right? This is the first experiment you have to perform. Right? Anybody? Any problem? Any other problem?
No, sir.
Why I choose this initially for the first practical? Because this is easy to understand, and later on also we have to, you know, understand the neural concept. So let us do the first practical this, and go AND gate, OR gate and NOT gate. It is very simple to perform. You just have to perform it, and here it is already mentioned. See, the lines represent the decision boundaries which separated two classes. This is a classification algorithm basically. The decision boundary will separate two classes if similar points lies on the same side of the decision boundary. Then if the similar points lies on the same point of decision, then it is okay. Then your result is okay. If you segregate it like this, then your equation will become this, and then the decision boundary is incorrect. So in this practical we will learn how to, you know, how to set the decision boundary in a neural network. Yes, anybody? Anybody want to ask any question? Yes, Rahul Tanwar?
No sir, clear है.
Clear है? Okay, then what I'll do, I'll share this link, virtual IIT lab, बॉम्बे का ये वो है हमारे पास, and इसके अंदर ना बहुत सारे प्रैक्टिकल्स हैं, but I want only first practical, you should have to do it from here. खाली first practical को आप इसको perform करेंगे. We'll go to the home, labs. Okay, I'll send this lab, this link to you. नेक्स्ट क्लास में हम लोग डाटा सेट्स पे काम करेंगे और डिफरेंट मशीन्स के बारे में पढ़ेंगे कि इसकी कोडिंग जो है कहाँ पे हो सकती है. दिस इज द फर्स्ट प्रैक्टिकल, सो आई थिंक दिस you should go start with this first initially. It is easy also to perform. What you have to do, everybody have to go to the respective gates, then start simulation, or not start simulation directly. First of all you have to rearrange the boundary. Let us do the NOT gate. Yes, this is the NOT gate. Truth table, no. Yes, so let
Sir, let me not get one.
अभी नोट गेट हुआ नहीं ना सर, एक मिनट रुको.
Not get में एक ही आती है.
देखिए अब नोट गेट को हम ले रहे हैं. यस, ये सिंगल आ गया. दिस इज अ नॉट गेट नाउ. नाउ व्हाट यू हैव टू डू, you just have to segregate the, set the threshold first, and then you have to check the truth table, start the simulation and check the truth table whether it comes correctly or not. Your threshold is 0.5, so for 0.5 0 is less than 0.5, then it is okay. Then expected is 1, that is, but your expected from the output is 0. Output from the neural network is 0. And when input is x, so this is 1. 1 is greater than this, then it is 1. It means this is not clearly, this simulation is not clearly done. So what we have to do, we have to segregate them like this, not like this. We have to set threshold like this, and weight we have to do, because here the weight multiply by x. So if you make it 0, if you make it slightly near to the 0, and threshold is like this, and let us start this again. Zero is less than 0.2, so you have to set it like this. The condition must be failed. So if the condition is failed, then only the output is 1. Now you tell me how to set. Yes, Mohammad Asif, what value of weight we have to set?
Sir, more to point B, I guess.
More towards B.
Yes, sir.
Okay. Like this.
Yes, sir. I am expecting the right result from there.
Sir, the answer would be 0, whatever be the value, because x is 0 and the y dash is equals to w1 into max. Sir, x is 0, so whatever be the value of w1, it will result 0, sir.
Yes, so, but here it is not coming now.
Yes, expected is 1.
But for 0, so what we should have to do? Either you have to select this line near to this or this boundary line.
So w1.
See, this is a threshold. Threshold is I set it 0.6, right? Now here it comes to be 2.35. If 2.35 is more than 0.6, let me start this. It is 0.
Sir, x is 0, so
it is true, na? If it is true, then output is wrong.
yes.
You have to make it false. So for that, what should I have to do?
सर 0 से जो टकराएगा वो 0 बन जाएगा, क्या करें इसका?
सोचो।
मल्टीप्लाई भी है।
तो आप थ्रेशोल्ड को कम कर दो। थ्रेशोल्ड को नेगेटिव ले जाएं?
हाँ सर, तब हो सकता है।
अब देखते हैं, चलो।
अब हो जाएगा सर, अब हो जाएगा।
बिकॉज यहाँ से तुमने बिल्कुल ठीक पकड़ा कि 0 से जो टकराएगा 0 आ जाएगा।
हाँ सर, हो गया सर, ट्रू हो गया।
अब ये ट्रू हो गया ना? नाउ इट कम्स टू बी 1।
यस सर।
Yes.
Done,
our result, right? So in the same way you have to think.
Okay.
Right? So this is not an easy task. You have to perform each and every gate, NOT gate, NOR gate, and this is the first practical, and you have to make it in your lab file also, right? अब
तो
lab file में
ये properly segregate तो हुए ही नहीं,
मतलब segregated का मतलब यहाँ पे ये है, actually this is a classification algorithm, but I tell you, and what I told you कि आपको weights को इस तरीके से रखना है कि वो आपकी गेट की सिमुलेशन को accurately दे, ठीक है?
So basically सर, we can check from the truth table कि हमारा आउटपुट ठीक है या नहीं, because थ्रेशोल्ड चेंज हो सकते हैं सर, कोई भी अपने हिसाब से रख सकता है।
हाँ,
तो आउटपुट वुड बी इक्वल अगर हमारी ट्रुथ टेबल सेटिस्फाई कर रही हो चीज़।
हाँ, और अगर नहीं कर रही है तो आपको बस ये वेट्स को और इसको चेंज करना है।
ओके सर,
थ्रेशोल्ड को चेंज करना है, राइट? So you just go through, you all should go through this and perform this and send me the file. For the sake of convenience, you can make an e-copy for that, e-copy of this. I don't have any issue. You just generate an e-copy where you have to write the aim, the theory also you have to include. You may copy paste it from here, no problem. And for simulation, what I want, you once you run this, you will get a accurate result. So what I want, you should write a table. You have to put this truth table and this as a snapshot. Like when you get the correct one, you have to tell at the result, in the result you have to tell these are the weights, and for these weights this is the output, right?
Okay, sir.
So you just prepare this, and I'll create a separate link for this for assignment for lab submission. Okay.
Yes, sir.
Okay, sir.
I think everybody clear this thing.
Yes.
Okay, right. So soon after this class, I'll send you a link of this lab. You just go ahead and perform all the practical and prepare a lab file and send it. Submit it through on an assignment link. I'll create a separate assignment link for an lab. So first assignment you must have to submit before the next lab session, right? So I'll give you time till today is 27. So I'll give you time till 3rd of September. Right?
Okay, sir.
Right?
sir.
Right?
Yes.
Okay. Then I'll ending this class and sending you link on your WhatsApp group.